Hello all, welcome to the new video of Signals and Systems. In this video, we'll see how to calculate gain margin. So, if you're watching this video, I hope you are aware about the basic concepts of control systems and you are aware about the stability. So, concept of stability such as Barkhausen criteria, etc. So, if you are not aware, I recommend you to watch the videos of Barkhausen criteria and learn some control system concepts, and then you can watch how to calculate gain margin video. So in this video I'll be showing you how to calculate gain margin from a transfer function. So this is a standard question which is asked in almost all competitive exams such as GATE, IES and other examinations. So it will be useful once you watch the video and you can you can know the steps and so that you can solve those problems in your examination, and also you can uh, appreciate the concept of this gain margin, so that when you design a control system you will know how to design your system and how to vary your gain. Okay, so let's see the definition of gain margin. So the gain margin is the amount of gain, increase or decrease required to make the loop gain unity. This is the loop gain, okay, unity at a frequency. This is the frequency scale at a frequency where the phase angle is minus 180 degree. So let me repeat again, gain margin is the amount of gain, increase or decrease. In our case it is increase at a frequency where the phase angle is minus 180 degree. So that is the simple definition of gain margin. So let's see one example. So it will be clear. So this is the Bode plot for G of j omega and H of j omega. So going by the definition of gain margin, we can write gain margin as 1 over magnitude of G of j omega into H of j omega at omega is equal to omega Pc. So this omega Pc is called phase crossover frequency. That is, it is the frequency at which the phase angle of G of j omega and H of j omega is minus 180 degree. So in this way we can write the gain margin. As you saw in the Bode plot, we drew Bode plot for G of j omega into H of j omega. Okay, so it is simple. Okay, at C, for example, if the gain value of G of j omega and H of j omega at minus 180 is say 5, gain at, that is value of this is 5 at minus 180 degree, then gain margin will become 1 over 5, such that if, this is the gain which needs to be increased or decreased to make the loop gain unity. Okay, the term increase or decrease refers to the value of in decibel. Okay, this gain is not in decibel, so that's the only difference. So if you say that the value of G at minus 180 degree is X, then the gain margin is, that is GM, will be 1 over X. So you should remember this formula to solve any problems. Okay, so the gain margin is nothing but the gain which needs to be added, that is increased or decreased, such that the loop gain is unity at this frequency, at this phase angle. Okay, so let's see some example. So let's see the question. The open loop transfer function of a feedback control system is that is they have given g of s into h of s is equal to 1 over s plus 1 whole cube. We need to find the gain margin. So let's see how to do that. Our first step will be find out omega pc, that is phase crossover frequency. To be precise, find the frequency at which phase angle is phase of this is minus 180 degree. Okay, to do that, put s is equal to j omega in this equation, say equation 1, that is g of j omega into h of j omega is equal to 1 over j omega plus 1 whole cube. So the phase of g omega and j omega into j omega will be equal to phase of this numerator is 0 and phase of this j omega plus 1 whole cube is minus 3 tan inverse of omega. So this omega will become omega pc if this phase is equal to minus 180 degree. Okay, so we are interested in finding what is the value of omega when phase is minus 180. So we can write minus 3 tan inverse of omega pc is equal to minus 180 degree. So this is simple. This will become 60 degree. So omega pc is tan 60 degree, which is equal to root 3. This is in radian per second, since we are talking about omega, not frequency f. Okay, so this is the phase crossover frequency, which is root 3. This is the step 1. So we have completed the step 1. Next, we'll use the formula for gain margin and we'll find out the gain margin, then subsequently convert it into decibels, because gain is usually expressed in decibels. So this is the definition of gain margin. So we are going to find out the magnitude of g of j omega and h of j omega at phase crossover frequency. So in a given question, the magnitude of this g of j omega and h of j omega can be expressed like this on the right hand side of the equation. As you can see here, we have replaced s with j omega. So magnitude, we have applied magnitude to this term. So for any complex term, say a plus jb, the magnitude of this will be equal to root of a square plus b square. Okay, so similarly the magnitude of j omega plus 1 can be expressed as 1 over root of this is omega square plus 1 square. 1 square is 1, so we can write it as omega square plus 1 whole cube. So by the definition of root, we can further express this as omega square plus 1 upon 3 raised to 3 by 2. Sorry, it will be omega square plus 1 whole raised to 3 by this 2, which has come from root sign. So if we want to find out the magnitude at omega is equal to omega pc, we need to substitute the value of omega pc in the place of omega. So the phase crossover frequency in our case is root 3 radian per second. So by omega pc we mean that what is the frequency at which phase angle is minus 180 degree. So we put this here, it will become 1 over root 3 whole square will be, this will be root 3 whole square plus 1 raised to 3 by 2, and this can be written as 1 over root 3 square is 3, 3 plus 1 is 4, so 4 raised to 3 by 2. This will become 1 over 2 raised to 2 into 3 by 2, so this will get cancelled. This will be 1 over 8. So this is just the value of g of j omega and h of j omega. So the gain margin will be 1 over 1 by 8. This is nothing but 8. So this is the value of gain margin. Okay. So usually we express this gain margin in the terms of decibel. So if you want to express it in decibel, you can go ahead and add 20 log of 8. This will be in decibels. Okay. So that's it. This is how we need to calculate the value of gain margin. So more questions are in the below link in the description. You can visit the link given in the description and solve the questions related to gain margin. For any doubts, please use the comment section. So that's all for now. We'll come up with next video mostly about how to find out the phase margin. Thank you.